Introduction to Chromatography. By the end of this lecture, you should be able to define chromatography, state the main components of chromatography, and explain the principles and separation process. Before we start discussing what is chromatography, let's recap what you did in the lab. So this is an animated version of what you did in the lab. You prepared the chromatography paper and you have spotted a standard and also an unknown sample. You filled in the beaker with a pre-prepared solution and you put in the chromatography paper into the beaker. You let some time to pass by while you wait for the chromatography to develop, and as you can see, spots starts to move and also your sample starts to have two spots. So again, you first started with one unknown sample, and as you let the chromatography to develop, you start to see your unknown sample has two spots. Now, what does this say about chromatography? What does chromatography do? Chromatography actually separates what is in this particular sample. So, chromatography is actually a method used to separate or analyze complex mixtures. It's not so different compared to other various types of separation techniques. As you've seen before, separation can be done by centrifuge, decantation, distillation, and drying is still separation technique. Chromatography is also one of the separation technique. So we will be covering chromatography in this course and also electrophoresis. So going back to your experiment from the other day, you know now chromatography is a separation process, but what is the component needed to separate the sample? Obviously, you have your sample, and two most important things in chromatography is a stationary phase and a mobile phase. So, a sample will have different affinity towards the mobile phase or the stationary phase. Due to this differential affinity, that is why separation can happen. So what happens on your paper the other day is the mixture has a differential absorption between the stationary phase, your paper, and also the mobile or the moving phase. So that is also called adsorption chromatography. Now a little history regarding chromatography before we move on. Okay, so chromatography is actually derived from a Greek word which is chroma, and graphene means that writing with colors. So the first person who developed chromatography is a Russian botanist called Mikhail Svet in 1903. He first separated the pigments in chlorophyll extract. So he used calcium carbonate as his stationary phase and petroleum ether as his mobile phase. So this is the results that he got at the end of his experiment. He found out that there are other pigments in chlorophyll extract. So what he did is he took an empty column, filled it up with calcium carbonate. In his case, he used chalk, and fill it up with petroleum ether to make up the environment of chromatography. And he put in the chlorophyll extract. Now you remember that chromatography is a separation process to see the differential affinity between the stationary phase and the mobile phase. So you need to keep the mobile phase moving, and it is said, or it is called, a mobile phase. So you have to keep adding the mobile phase in order for the sample to start moving down the column. When the sample starts moving down the column, you can start to see there are two pigments in the sample and they have differential affinity towards the stationary phase. As you keep on adding the mobile phase, as you can see, they start to move downwards and their movement and their affinities starts to get bigger. And as you add more mobile phase, you start to separate the first pigment and you start to isolate the first pigment and pour even more mobile phase. You will get to isolate the second pigment until there is no other pigments left in the column. So let us see what actually really happens in the column for further understanding. So this is a column filled with the calcium carbonate. And let's zoom in to see what actually really happens in the column. So in the column, there are properly packed and loaded calcium carbonate in the column as such. And these are the moving mobile phase for animation purposes. So just remember that the mobile phase is constantly moving, so I've taken that picture out, but just remember that it keeps on moving. Then as I add in the sample on the top of the column, as you can see, with constant addition of mobile phase, I will start to see some separation. So as you can see, the first pigment and the second pigment has differential affinity. In this case, they have differential adsorption towards the stationary phase. So that is what happens in the column of chromatography. So I hope you understand by now how chromatography works. It works by separating mixtures according to differential affinities, and it must have one stationary phase and a mobile phase in order for separation to happen. So for example, in this case where you have this mixture and you let separation to happen, and as you can see, you have 4 components in this mixture. From this movement, you can know which components prefers the stationary phase and which one prefers the mobile phase. For example, this yellow component, it moves the same distance as the mobile phase, therefore it prefers the mobile phase compared to the blue components. So I hope this lecture can help you understand chromatography better. Chromatography can be used to analyze, identify, purify, and quantify a mixture or a component in a mixture. And you can also use it in pharmaceutical company, hospital, law enforcement, environmental agency, and manufacturing plant. There are actually many types of chromatography, but the highlighted ones are the ones that will be covered in this course. So the different type of chromatography comes with different principles of absorption. For example, in the absorption type of chromatography, it is due to polarity. This will be further discussed and also explained in the class and also in other types of chromatography. This just shows that if it depends on polarity, it can be between 3 different methods. First is what you did in the lab, which is solid to liquid. solid being the paper and liquid is your mobile phase. So it is an absorption type of chromatography. Or you can also have partition type of chromatography where you have liquid to liquid or liquid to vapor. Liquid to liquid is due to solubility, and also liquid or to vapor is also due to solubility. This will be covered in HPLC and GC lectures. So an example of adsorption and its application is as such for your reference. Thank you.